Assalamu alaikum. My name is Ali Khan, roll number 21 TE77. Today we discuss the lab number 7 of DSP. So in lab number 7 we discuss frequency analysis and digital sequences. Now we move toward the lab objective. So the lab objective of this lab is study digital sequences in terms of frequency spectrum and contribution of high frequencies in a sequence and contribution of low frequencies in a sequence. Now we move to the task number 1. So in task number 1, considering the following sequences, which is x is equal to 1, 2, minus 1, 1, minus 2, 0, 2, and 3, and plot the signal in matlab up to if sampling frequency is 2 kilohertz sampler per second. Then first redraw the sequence after removing frequencies above 5 kHz. Observe and discuss the effects of this removal of frequencies. The second one, redraw the sequence after removing frequencies above 7 kHz. Observe and discuss the effects of this removal of frequency. Now we move toward the MATLAB. Here, in MATLAB code, x is equal to which was given in the lab manual, and a sampling frequency which is 20 kilohertz, and generate time factor which is t is equal to 0 to length x minus 1 or sampling frequency, and plot x and t and x level for time which we define, and y level for amplitude, and title for original signal. So the second part of this task, which is the cutoff frequency, which is equal to 5 kilohertz, normalize the cutoff frequency and design for low pass fire filter and apply the filter to the signal, and plot filter signal and x label which is time, and y label which we define for amplitude, and title which we define for signal with frequency which is less than 5 kilohertz. And the third part of this task, which is the cutoff frequency, is equal to 7 kilohertz, and normalize the cutoff frequency and design a low pass fire filter, and then apply the filter to the signal, and plot t filter signal and x level which is time, and y level which is amplitude, and title with signal with frequency which is less than 7 kilohertz. Now we move to run this code. Now we just wait for a few seconds. So here you can see this is the signal with frequency which is less than 5 kilohertz, 7 kilohertz, and this is signal with frequency which is less than 5 kilohertz, and this is signal with frequency which is less than 7 kilohertz. Now we move to the lab manual and task number 2. Now here in task 2 says that use the following audio sequence which is music wave and calculate DFT, and second one, remove the upper half of frequencies above sampling frequency were 4, and observe the changes by listening the audio, and the third one, remove the lower half of the frequencies below sampling frequency were 4, and observe the changes by listening the audio. Now we move to the word the MATLAB and the lab task 1. First we remove this output. So here this is the first part of the second task, and first we define audio read, which was in the music form, which was given in the lab manual, and then calculate the DFT using A50, which is DFT is equal to A50 of Y, and then obtain the frequency axis for plotting, and length of the audio sequence, which is n is equal to length, and f is equal to 0 to n minus 1 multiply some frequency over n. This is for frequency axis, and then plot the magnitude spectrum, which is in plot f absolute DFT and x label for frequency hertz, and y label for magnitude, and title DFT of audio sequence. Now we move to this matlab code. Now we just wait for a few seconds to run this task. So this is the first part of the second task. Now we move to the second B part of the second part task. Here we define audio read, which was given in the lab manual, which was in the form of music, and then find index corresponding to sampling frequency over 4, and index is equal to around n over 4, and then the offer of half of the DFT coefficients. DFT index plus 1 and n is equal to 0, and then reconstruct the audio sequence using the inverse DFT I A50, and modified signal is equal to I A50 into DFT, and then play the modified audio. Now we move to run this task. First we remove this output. Now we just wait for a few seconds to run this task. So this was the second one. Now we move toward the part C of the task number 2. So as we know that this is the audio read which was given in the lab manual, which is in the form of music view, and then find the index corresponding to F, fs over 4, and index is equal to round n over 4, and then zero out the upper half of the DFT coefficients, and reconstruct audio sequence using the inverse DFT, and modified signal is equal to inverse IA50 into DFT, and then play the modified audio. Now we move to run this task. This was the third task which is performed in MATLAB already. So thank you for watching.